morning. My name is Joby Ryan Naguno, and I'm here to report about solar energy. And solar energy is radiant light and heat from the sun that is harnessed using a range of ever evolving technologies such as solar heating, photovoltaics, solar thermal energy, solar architecture, molten salt power plants, and artificial photosynthesis. It is an essential source of renewable energy, and its technologies are broadly characterized as either passive solar or active solar, depending on how they capture and distribute solar energy or convert it into solar power. And also, active solar techniques include the use of photovoltaic systems, concentrated solar power, and solar water heating to harness the energy. And passive solar techniques include orienting a building to the sun, selecting materials with favorable thermal mass or light dispersing properties, and designing spaces that naturally circulate air. And we have here photovoltaics, and photovoltaics directly convert solar energy into electricity. They work on the principle of photovoltaic effect, and when certain materials are exposed to light, they absorb photons and release free electrons. This phenomenon is called as the photoelectric effect. Photovoltaic effect is a method of producing direct current electricity based on the principle of the photoelectric effect. And based on the principle of photovoltaic effect, solar cells or photovoltaic cells are made. They convert sunlight into a direct current electricity, but a single photovoltaic cell does not produce enough amount of electricity. Therefore, a number of photovoltaic cells are mounted on a supporting frame and are electrically connected to each other to form a photovoltaic module or solar panel. The commonly available solar panels range from several hundred watts, say 100 watts, up to few kilowatts. Ever heard of a 5 kilowatt solar panel? And they are available in different sizes and different price ranges. Solar panels or modules are designed to supply electric power at a certain voltage, say 12 volts, but the current they produce is directly dependent on the incident light. And as of now, it is clear that photovoltaic modules produce DC electricity, but for most of the times we require AC power, and hence solar power system consists of an inverter too. And next we have photovoltaic solar power system. According to the requirement of power, multiple voltaic modules are electrically connected together to form a PV array and to achieve more power. There are different types of PV systems according to their implementation. First would be we have PV direct systems. These systems supply the load only when the sun is shining. There is no storage or power generated, and hence batteries are absent. An inverter may or may not be used depending on the type of load. And we have here the second type of solar power system, the off-grid systems. This type of system is commonly used at locations where power from the grid is not available or not reliable. An off-grid solar power system is not connected to any electric grid. It consists of solar panel arrays, storage batteries, and inverter circuits. We have here in the picture the supply, or how the solar panels supply energy to our appliances. From the solar panels, it goes through the DC, or it goes through uh, that would be by DC with the battery. It's optional, by the way, and going to an inverter, so that makes DC to AC, and AC going to the meter or fuse box. And there's also the grid above, so that also is required to have the meter and fuse box working. And after the meter and fuse box, they go to our home appliances like our light bulbs, TVs, refrigerators, etc. So this is the typical grid connected PV solar system. And we have also the history of the solar photovoltaic effect. And first would be around 1839, it would be the discovery of the solar photovoltaic effect. And that is because a French physicist named Edmund Becquerel, only 9 years old at the time, discovered that there is a creation of voltage when a material is exposed to light. Little did he know that his discovery would lay the foundation of solar power. And on 1883, first 1% efficient solar cell is created. And that would be by 1883. As far as about 700 BC, humans know that sunlight could be harnessed as an energy source. But how could we capture that energy? Finally, American inventor Charles Fritz came up with a simple design using selenium on a thin layer of gold to form a device producing a modest but nonetheless groundbreaking 1% efficiency. And on 1954, the birth of photovoltaics, David Chapin, Calvin Fuller, and Gerald Person of Bell Labs in the United States are credited with the world's first photovoltaic solar cell. More specifically, these are the men that made the first device that converted sunlight into electrical power. They later pushed the conversion efficiency from 4% to 11%. And on 2015, the age of solar power. The solar power industry in Australia undergoes rapid growth during this period. As the cost of fossil fuels continues to rise, solar energy drops to record lows, as does the cost of rooftop installation. Almost every gizmo, gadget, and environment is capable of harnessing the power of the sun's unlimited resources, from luxury cars to airplanes, and in some cases, entire states and countries. And we also have advantages of having solar panels or solar photovoltaic systems and solar cells. And one of that would be solar cells used for power generation causes no noise, whereas generators or turbines of other methods causes noise pollution. Next would be the solar energy is free and renewable resource to generate electricity. It requires collectors and some other equipment for conversion of solar energy into electrical energy. And third, it does not cause much pollution compared to other power generating methods such as a thermal power plant, nuclear power plant, and so on. Next, the solar cells do not consist of any moving parts and hence requires a little maintenance for their operation. Next would be the solar power offers energy security by avoiding the general power system in which there is a possibility of power theft. And next would be the solar panel energy can produce 50% of the power required to house by installing the solar panels. Next, we have it is an everlasting infinite renewable energy source compared to other limited energy sources such as nuclear energy, coal, etc., which are estimated to last for 30 or 40 years. It can be considered as a job creating powerhouse if once the installation or construction of solar power stations is initiated, then it will offer more job opportunities for many engineering students. But if there's any advantages for solar powers, we also have disadvantages for this. And first would be the solar power energy generation entirely depends on the sunlight incident on the solar panels and which in turn depend on the climatic conditions. That means that if there's no sun, there should be we cannot store sun energy for us to have the energy on our appliances or on our home. And next would be installation cost of the solar panels. To use solar energy is very expensive, and the initial investments can be covered only after long term or many years utilization. And next would be solar energy can be harnessed in a limited period as the sunlight is available only during the daytime and sunny days. Thus, power can be generated only in limited time period and the power has to be saved in batteries for later usage. The batteries used to store solar power are very costly, huge sized, and need to be replaced from time to time. And next would be the power. The more electricity you want to produce, the more solar panels you will need, as you want to collect as much sunlight as possible. Solar PV panels require a lot of space, and some roofs are not big enough to fit the number of solar panels that you would like to have. Although pollution related to solar energy system is far less compared to other sources of energy, solar energy can be associated with pollution. Transportation and installation of solar systems have been associated with the emission of greenhouse gases. And when these panels enter landfills, valuable resources go to waste. And because solar panels contain toxic materials like lead that can leach out as they break down, landfilling also creates new environmental hazards. And we have here our solar panel process diagram. So from first, We have here the source, which is the sun, and the sun rays that be through radiation. So it goes through the solar panels. It absorbs energy from the sun and turns it into DC current. And going through number one would be number two, which would be the inverter. It inverts or it converts DC current into AC current and controls the electricity and production throughout the house. And we have here electric panel. This distributes the electricity to your home. And next we have utility meter. Any excess solar electricity will flow back to the grid through the meter. And lastly, we have utility grid. Provides electricity when you enter the amount or when you exit the amount produced by your solar panels. So the solar energy we have for or from the sun would not be a waste, since we have options here, or we have appliances here that will store the excess energy and will be used if we don't have any sunlight to outside, or we can use. So the batteries are very recommended for us to have electricity even at night. So let's go proceed, and we have here we have plants, or we have solar power farm in the Philippines. And first we have here will be the Calatagan Solar Farm near the foot of Mount San Pedro in Calatagan, Batangas, has earned the distinction of being the largest solar facility completed in the Philippines today. It spans 160 hectares and provides power to the western part of Batangas. Solar Philippines, a renewable energy firm led by 22-year-old entrepreneur Leandro Levesti, developed, financed, and constructed the 63.3 megawatt Calatagan solar farm at a cost of 120 million US dollars. That would be 5.7 billion in Philippine peso, and it boasts of 200,000 solar panels all in all. And here we have in Cadiz, Negros Occidental, Philippines, is a 132.5 megawatt solar power plant. And upon its completion, the facility, located in a 176 hectare or 430 acre land in Hacienda Pass, Barangay Tirampaan, and is the largest solar power facility in Southeast Asia upon its commissioning. Construction of the plant began in July 2015 with 2,500 greens employed during the facility's construction. 500 were employed for the plant's operations. The Cadiz plant was developed by Helios Solar Energy Co. and a joint venture between Thailand-based Select Solar Corporation and Gregorio Araneta Incorporated, and was commissioned by Singapore-based Equis Funds Group. Construction cost of the plant amounts to 10 billion pesos. And the third one we have for the Philippines would be a greenfield standalone solar farm and San Carlos Solar Farm, or SACASOL, is located inside the San Carlos Ecozone in San Carlos City, Negros Occidental. With a total gross capacity of 45 megawatts, the solar farm generates renewable energy to supply daytime peak power to the Visayas grid. Developed in four phases, Phase A would be 30 megawatts, Phase B would be 9 megawatts, Phase C would be 13 megawatts, and Phase D would be 10 megawatts. The project aimed to provide supplemental electricity in order to decrease dependence on fossil fuels and imported energy resources, thereby reducing greenhouse gas emissions and power generation by the use of renewable energy. Engineering services for this project were completed in 2016. And also, solar panels go through a lot of rigorous testing before they are certified for use in a solar system. They are exposed to extreme levels of humidity as well as extreme heat and cold, ranging from 85 degrees Celsius to negative 40 degrees Celsius. Once they pass these intense tests, they are deemed suitable for sale and installation. Maximum efficiency of solar panels is around 15 degrees Celsius and 35 degrees Celsius, during which solar cells will produce at maximum efficiency. Solar panels are made of silicon photovoltaic or PV cells, and electricity produced is affected by the surrounding temperature, which is in very hot conditions can reduce the benefits. Solar panels can get as hot as 65 degrees Celsius, at which point cell efficiency and overall output will be significantly reduced. Photovoltaic solar panels do not bear the risk of superheating because they do not contain circulating water, and they simply evacuate heat from each side of the panel. Unlike thermal panels, which is at risk of overheating for this very season, and not only dangerous for the installation but also costly to the owner. And we have the solar panel power output, and a solar panel's output is expressed in watts. On average, a domestic solar panel has a power output of around 265 watts, although it can range anywhere from as little as 225 watts to more than 350 watts. The higher the wattage of a solar panel, the more electricity it can produce under the same conditions. And also, you will ask how much power or how much power output does your new home need? This all depends on how much electricity you use, how much of your home you want your solar panels to power. If your household has a particularly high energy usage or you want to solely rely on solar panels to power your home, would recommend getting solar panels with a high output around 300 watts per panel or more. However, if you don't use much electricity day to day or only want solar panels to subsidize some of your home's energy usage, you can choose solar panels with a lower output of about 225 to 275 watts. And energy output of our photovoltaic system, the global formula to estimate the electricity generated and output of a photovoltaic system is E is equals to A times R times H times PR, which our in energy or E would be the energy in kilowatt hour, and A would be total solar panel area at meter square, and R would be the solar panel yield or efficiency by percent, and H would be the annual average solar radiation on tilted panels. Shadings not included, that would be on kilowatt hour per meter square. And PR would be performance ratio, coefficient for losses, range between zero point 0.5 and zero point 0.9. Default value would be 0.75. And that would be all for my solar PV, solar panels, photovoltaic system report, and thank you.